My name is Andrea Folli. I'm an academic researcher of the Danish Technological Institute in Copenhagen in Denmark. And I'm the project manager of the Light2CAT project. Light2CAT is an R&D project funded by the Framework Program 7 of the European Union, and it aims to develop innovative concrete able to help to improve air quality in cities. Light2CAT works through the implementation of photocatalysis into concrete and construction materials. What photocatalysis is a technology that uses active materials called photocatalysts, and these photocatalysts are components, solid materials that somehow mimic the effect of chlorophyll in plants. So they transform solar energy into chemical energy. The practical application is to reduce the amount of pollution in the urban environments. So once we've got these materials called photocatalysts into our concrete and the surface of the concrete is exposed to sunlight, the material becomes active, and once it is activated, it can degrade some species of pollutants contained in the air. For example, it can oxidize nitrogen oxide to harmless nitrates. And the same way, the photocatalyst also degrades organic pollutants present in the air. For example, it can oxidize and mineralize volatile organic carbons, or it can mineralize bigger organic molecules that usually cause dirt and stains on the surface of concrete or other materials. Doing this, we can give to the concrete a sort of easy-to-clean effect, because a lot of these molecules are degraded by the photocatalyst itself. We've got here two elements. One is just ordinary concrete, and the other element is the same concrete with photocatalyst in the structure. And we showed how by making just a sign with a blue marker on both of them and then apply some light, the mark that was actually made on the concrete element with the photocatalyst was partially faded by simply putting some line onto it. So photocatalysis applied to construction material is a technology that has been available on the market for more than 10 years now. Unfortunately, the main photocatalyst used, titanium dioxide, has the major limitation of being active only under UV light, which means that when we use this technology for a passive solar application, we can only exploit the very few percentage of UV light contained in the solar radiation. With our new photocatalyst, we can use more of the visible spectrum, and we could also improve the selectivity of the reaction.